welcome you all to online lecture 1 on theory of machines 2, a third year course. We'll start with the vision and mission of PCCOER Ravet. Vision of our institute is to be a premier institute of technical education and research to serve the need of society and all the stakeholders. While mission of the institute is to establish state-of-art facilities to create an art environment resulting in individuals who are technically sound, having professionalism, research and innovative attitude with high moral and ethical values. Already HOD sir and principal sir in their sessions discussed this in detail, so I'll just touch this and go for next slides. This is our vision and mission of our mechanical engineering department. The vision of our department is to be a premier department of mechanical engineering and research to serve the need of society and all the stakeholders. While there are 4 missions: to provide state-of-art facilities, to impart quality education, to undertake various value-added and add-on courses to make students technically sound and through professionalism, to collaborate with industries and academia, and to strive to transform the research and innovative attitude in the students and faculties, to inculcate high moral ethical values, national pride in students and faculties. This is about vision and mission of our department. There are 4 POs which a graduate must have after the engineering, and this can be measured after 4 to 5 years of engineering. The first PO, that is program educational objective, is to develop students sound in academic fundamentals, to understand, analyze and solve problems related to mechanical engineering, to build up students' ability to enhance their competence in research and innovation, to design product and process, to enhance employability of students to meet the employer's requirement at large and prepare them towards quality higher education. Fourth PO is to create awareness amid the students about professional ethics, managerial skills, social commitment, and lifelong learning. While there are 2 PSOs called as program specific outcomes to develop the knowledge and skills relevant to the field of robotics and automation by undergoing hands-on training. Second PSO is execute new ideas on product design and development with the help of modern computer-aided tools and other modern and emerging technology in the field of mechanical engineering. So these are about PSOs and POs of our department. These are the 12 program outcomes which are mandatory to all, specified by NBA. These all 12 outcomes an engineering graduate must have after completion of their 4-year engineering. The first one is engineering knowledge. He must have, the candidate must gain some engineering knowledge, problem analysis, design and development of solutions. So he must be able to design or develop something. Conduct investigation of complex problem. I can add something like the student must be able to, or student must have this knowledge, this outcomes. Modern tool research, he must be able to use some modern tools, different softwares. The engineer and society, environment and sustainability, ethics, individual and teamwork, communication, project management and finance, and lifelong learning. These are the 12 outcomes, program outcomes. Now we come to this. We'll start with the course introduction. The course is Theory of Machine 2, and the pattern of the course is 2015. Well, the code of the course is 30-20-43. I'm going to take this for both divisions A and B. When you talk about examination scheme, paper pattern for in-sem is 30 marks and end-sem is 70 marks. You must remember, in second year, up to second year, you have online examination, but in third year, you don't have any online examination. All examination, theory examination. First, there will be 30-mark examination, that is in-sem, based on first 3 units, and then a 70-mark examination based on all 6 units, but weightage of the first 2 units is 20 marks. First 3 units is 20 marks, while last 3 units is 50 marks. And in examination, university examination scheme, the oral weightage is 25 marks, external oral is there, as a term work is for 25 marks. So total weightage by considering examination point is 150 marks. Teaching scheme, there is 3 hours per week for theory and 1 hour per week for practical. While there are, you will gain 3 hours credit, not ask 3 credits for a theory, while 1 credit for term as well as oral. Which prerequisites for the subjects are: first one, we must have some strong knowledge of engineering mathematics, engineering physics, engineering mechanics, theory of machines 1. How these subjects are useful to learn the subject theory of machine 2, we'll discuss at a particular point. I will tell you background of that these subjects, that is math, physics, mechanics, and term 1. Also, this course is prerequisite for engineering subjects like DME 1 and 2, that is design of machinery element 1 and 2, dynamics of machinery, mechanical system designs. While course objectives, remember, for developing any course, there are some set objectives. As we are bound to University of Pune, we need to follow some objectives designed for this course. So this course having some 6 objectives. The first objective is develop competency in understanding of theory of machines. To develop competency in understanding of theory of all types of gears. So we should understood, student must be able to understood theory of all types of gears. That is first objective. Second is to understand the analysis of gear train, and third one is to develop competency in drawing the cam profile. If you see, in these first 2 objects are based on gear and gear train, and third one is based on another mechanism called as a cam profile, and to develop the competency in drawing cam profile. Well, fourth objective is related to synthesis, which is to make student convergent with synthesis of the mechanism. Well, fifth objective is to understand stepless regulation, and the sixth one is to understand mechanism for system control like a gyroscope. Along with these objectives, we have some course outcomes. There are 6 course outcomes, and this course outcome, each course outcome, in this, if you see in the bracket I mentioned, which level student will earn or student will learn that skill sets. So what skill set student will having based on Bloom taxonomy level. The course outcomes are CO1, to understand the fundamental of gear theory, which will be prerequisite for the gear design. Means student will be able to understand fundamental of gear theory, which will be prerequisite for the gear design. So at the end of the course outcome, student must be able to understand fundamentals of gear theory. He must be able to. Then he must be able to perform force analysis of spur, helical, bevel, worm, and worm gear. That is, he is able to apply the knowledge he gained during these lectures. So first outcome is talking about remembering, understanding, and the second outcome is talking about applying. The student will be able to remember, understand the gear theory. Student will be able to apply the knowledge of gear trains for force analysis. While analyzing, third one is related to analyzing, where it consists of student will be able to analyze speed and torque in a cyclic gear train, which will be prerequisite for the gearbox design. So here it is related to analysis of gear train. Next one is to design cam profile for the follower motions and understand the cam phenomenon as well as advanced cam curves. So the fourth outcome is related to design of cam follower and to understand the cam jump phenomenon as well as to design advanced cam curves. Fifth one is related to evaluating, that is synthesize the forward mechanism with analytical and graphical methods. So student able to evaluate these methods. And the sixth one is again analyzing and applying, to analyze a gyroscopic couple or effect for stabilization of ship, aeroplane, and 4-wheeled vehicles. So they must able to have knowledge of gyroscopic couple and to see effect for stabilization of ship, aeroplane, as well as 4-wheeled vehicle. Next one is applying, which is appropriate drive for given application, that is step or stepless. This is COPO mapping table, not related to for student that much. This is syllabus of unit number 1, which consists of basically terms and analysis of spur gear, which first introduce classification, then terminologies, then definitions of inner cycloid, conjugate profile, then path of contact, arc of contact, conjugate action, interface intercutting, and finally force analysis and friction in gears. The weightage is 8 hours, while unit number 2 is related to other gears like helical, bevel, worm, and worm wheel. Its force analysis is terminologies, and the weightage given by university time is 6 hours. Next one is gear train. In gear train, we are going to discuss types of gear trains, analysis of episodic gear trains, holding torque. That is basically we are going to study different types of gear trains and then its analysis, and more focused on epicyclic gear train. In fourth unit, we are going to study cam and follower mechanism, its design, different types of cams, different types of followers, different phenomena related to cam and follower, and how to draw cam follower profile, along with some advanced cam course also introduced at the end of the unit. And also, of course, weightage data again. So the next unit is synthesis of mechanism, where it consists of only theoretical methods. Graphical methods will be discussed in practical, and the weightage for this unit is 6 hours. Time weightage, I'm saying. Then last unit is combination of stepless regulation and gyroscope. In stepless regulation consists of only theoretical treatment like CVT, IVT, and finally gyroscope. Gyroscope effect, its couple, and then its application for ship, aeroplane, and four-wheel vehicles. This is all about theory part. Now in practical portion, we need to cover 7 compulsory practicals. This is a list of practicals we need to cover. One practicals are based on mostly initially we will see how to draw a inward gear to profile with the rack cutter. Then practical related to manufacture of gear to profiles, not manufacturing actually, said manufacturing, but we are going to plot. They're going to draw that gear to profiles with the help of a rack cutter. Second one is kinematic analysis, a self-study practical of synchro mesh, central gearbox, or differential gearbox. Third one is speed torque analysis of episodic gear train. This is also performance practical, in which we have one setup for episodic gear train, and on that setup we are going to find out speed and torque analysis. Fourth one is to draw cam profile. The sheets are there. We are going to design different cam profiles based on input given. Again, each one also based on sheets. Here we need to synthesize proper mechanism. As I told you in the theory portion, we are going to discuss only analytical methods, but here in practical session we will discuss graphical too. Sixth one is related to gyroscopic effect. We are going to verify the gyroscopic effect with the help of apparatus we are having. Seventh one is to study continuous transmission and infinite variable transmission. So to study of CVT and IVT is practical. So if you see in here, there are some study practicals, there are some sheets, and there are some performance-based practical. So this is compulsory practicals, 7 practicals. Along with this part A, we have some practicals, the list of practicals given by university. Out of this, we need to complete at least 2 practicals. So 7 plus that 2 here, total 9 practicals we need to perform compulsory. Here it consists of draw a conjugate profile for general type of gear tooth, verify cam jump phenomenon, synthesize a proper mechanism based on Prudence equation using any programming language, measure the range of speeds obtained by any one type of continuous variable transmission device, and industrial visit to understand machines and mechanism. Out of this, any 2 we need to perform. The textbooks, S.S. Ratan, Theory of Machines, 3rd edition, Macro Division. Day 1, Theory of Machines, 3rd edition. While A.J. Ambekar also nice book, Mechanisms and Machines Theory. Then N.K. Mehta, then J.J. Ukar, G.R. Pinnock, and J. Shikle, Theory of Machines and Mechanisms book. These are the textbooks where you get most of the syllabus in these books. In reference books, Ghosh Malik, Theory of Machines and Mechanism. Then Mechanics of Machines by Hanna and Stephens and Edward Arnold publication. While R.L. Norton, then Sadhu Singh, D.K. Pal, Dr. B.P. Singh, C.S. Sharma's book on this on theory of machines are reference books where we get some topics. We will not get all topics in one reference book. This is all about exam pattern of this subject. Consists of a weightage of in-sem examination and mid-sem examination. In in-sem examination, unit 1 weightage is for 10 marks, unit 2 weightage is for 10 marks, unit 3 weightage is for 10 marks, so 10, 10, 10 each unit. And if you see theory and numerical weightage, theory weightage for 4 marks and numerical for 6 marks for first unit, 4 marks theory, 6 marks numerical for second unit, while for third unit, 4 marks theory and 6 marks numerical, or completely 10 marks numerical. So maximum weightage of numerical, if you consider here, there will be 22 marks. So big weightage for numericals in end-sem examination. And then end-sem examination, the pattern is like this. First 3 units consist of 20 marks, and last 3 units consist of 50 marks. Out of that, 16, and last unit consists of 18 marks. So 16 plus 16 plus 18, total 50 marks based on last 3 units. By for first 3 units, there are only 20 marks. This is all about exam pattern. In introduction lecture, we will also discuss about a brief about a gears. So before starting for gears, we'll see here power transmission systems. If you don't use, if you need to transmit power between two shafts, let's say from shaft 1 to shaft 2 here, there are different options, there are different alternatives. And that alternatives will select based on distance between the shafts. If distance between the shafts between which I need to transmit the power is more, then we generally prefer systems like belt and conveys like this. While if that is means if large central distance is there, then we prefer belt or rope drive. While if central distance between the two shafts, let's say this shaft 1 and this is shaft 2, here I want to transmit power, then we may prefer chain drive. So chain drives are used for a median central distance of the shafts. And if central distance between the two shafts where we need to transmit the power is too low, small, then we prefer gear tooth or gears. You can see in the diagram, two shafts having very small central distance are joined by using a two gears. Maybe some other type. In the first diagram, you can see these are the spur gears, while it is some other gear like worm and wormtail. In detail about this gear, we'll see in next lecture. So this is all about how gear drives or chain drives or belt drives are used to transmit the power. Now we just see the history of gears. We've seen these gears are used from old ages, like earlier 1200 years ago, the people used these gears made of woods to operate the mechanism used for driving doors of temples and caves. So it is used 1200 years ago. Next, we can see basically before gears are derived, people use friction disc to transmit the power. But the problem with this disc is actually it should rotate in opposite direction. The problem with this disc is slip may occur. And hence to avoid the slip problem, we use gears to transmit the power. Gears means just we made additional projections on that periphery. So gears we can call it as a disc only, but with projections cut on its periphery. So it is next advancement of friction disc. The problem with disc I told you, there will be a slip problem. And to avoid the slip, we'll use gears. This is one more related to history of the gears. This shows early example of gears date from 4th century BC in China, which have been preserved at the Luoyang Museum in China. So you can see these gears are used in 4th century. But this is one more. The earliest preserved gears in Europe were found in the Antikythera mechanism, an example of very early and integrated gear device designed to calculate astronomical positions. Its time of construction is now estimated between 150 to 100 BC. You can see this now, it's old gear, but it is used in that era. And that means between the 150 to 100 BC. You might have seen some clocks on old buildings, but the clocks, old clocks basically, the clocks are using the gear mechanism. You can see this one to drive the one clock mechanism. This many gears are there. So this is what Salisbury Cathedral in England still was its oldest clock made in 1386. So this is mechanism used to drive that clock. You might see this kind of clocks many times. Tooth gears are used for the clocks of building in Middle Ages to operate their mechanism. Okay, this is all about history of gears. In next lecture, we'll discuss about classification of gears, gear to terminology, fundamental law of tooth gearing, inner-root gearing, concept of path of contact, arc of contact, interference, undercutting, and finally, minimum number of teeth on gear and pinion, and then force analysis of gears. This is from first lecture. Thank you.